Welcome to our quick summary series. This is a quick fire summary video. For a longer, more detailed explanation, head over to RevisionRight.com. Make sure you subscribe to our channel and turn on that notification bell so you don't miss our 10 minutes a day daily revision, uploaded every day. And if you do enjoy this video, please give it a like. You'll remember from the previous video that an acid is a substance that releases H+ ions when dissolved in water. Acids can be strong or weak. This depends on how strongly they ionize in water. Strong acids completely ionize. Weak acids do not fully ionize. Let me explain. Here I am going to draw a rather large beaker. And this represents water. If we dissolve lots of hydrochloric acid in water, and we do that here, they all split up. In other words, they completely ionize. You see lots of H+ ions here. This is a property of a strong acid. They completely ionize. Let's draw another beaker. And again, here we have water. Here we're going to look at hydrofluoric acid, and we're going to dissolve it in water, as we've done here. They do not all split up. In other words, they do not completely ionize. You can still see some HF, hydrofluoric acid, in the water, not the H+ ions. This is a property of a weak acid. pH is a measure of the concentration of high H+ ions. For every decrease in pH of 1, the amount of hydrogen ions increases by a factor of 10. This means that a substance with pH 3 has 10 times more hydrogen ions than a substance with pH 4. A substance of pH 2 has 100 times more hydrogen ions than a substance of pH 4. A substance of pH 1 has 1,000 times more hydrogen ions than a substance of pH 4. This can be written as H+ ion concentration changes by a factor of 10 to the power of minus x, where minus x represents the difference in pH. Let's go through a worked example. A student added a strong acid to a weak acid of pH 5. The pH of the new solution was pH 2. By how many times did the concentration of H+ ions increase? Step 1. Work out the change in pH. It started at 5, it ended in 2. That's a change of 3. We then need to put this into the equation. The factor of H+ ion concentration equals 10 to the power of 3, which means it increased by 1,000. Here is a weak acid because it has not been completely ionized. Remember, concentration is how much of a solution there is in a given volume. Strong acids are not the same as concentrated acids. In this example, there is lots of solute, so it has a high concentration, but they have not completely ionized. So it is a weak acid, a concentrated acid, but a weak acid. You have now learnt about what makes a strong acid and a weak acid, and the difference between strong and concentration acids. You will find a summary of this information below. Make sure you test yourself using the quiz on RevisionRight.com. Remember to subscribe to our channel and turn on that notification bell so you don't miss our 10 minutes a day daily revision uploaded every day. And if you did enjoy this video, please give it a like. We are super excited here on RevisionRight.com about the launch of our brand new website. I just wanted to quickly take you through some of the amazing features on our site. Here you can make a profile just like you can on other social media websites, but this one is all about revision, the very first of its kind. You can write in questions here, for example, so can someone help me with the function of bile? You can post it and one of our tutors or another member of the community will get back to you. We're really excited about the revision community we can make here. If you go to the Learn part, here you can have access to text, videos, and quizzes from all the topics you will need in GCSE Science. You'll have access to all the summary videos that we have on YouTube, but also much longer videos that aren't available on YouTube that go into real detail on each topic. We will also have daily and weekly revision challenges for each biology, chemistry, and physics. New challenges each day. And this will link in with the leaderboard so you can compare how you're doing to how everyone else is doing. And really excitingly, you can also book extremely cheap group and private revision classes with one of our tutors. We'll be updating the website all the time, so head on over to RevisionRight.com and sign up for a free account today.